In this video, we will learn Applied Science Physics Practical. Applied Science Physics, the code is 22202. This is for semester 2. The experiment number 1 is Young's Modulus. Title of this experiment is Use Searle's method to determine Young's modulus of the wire. The course outcome is select relevant material in industry by analyzing its physical properties. Resources required are Searle's apparatus, two long steel wires of same length and diameter, a set of slotted weights, weight hanger, dead load, and meter scale. Experimental setup is as shown in the diagram. Searle's apparatus consists of two metal frames F1 and F2. Each frame has a torsion head at the upper side and a hook at the lower side, and these frames are suspended from two wires AB and CD of the same material, length, and cross section. The upper ends of the wires are screwed tightly in two torsion heads fixed in the same rigid support. A spirit level rests horizontally with one end hinged in the frame F2. The other end of the spirit level rests on the tip of the spirometer screw, fitted in the frame F1. The spirometer screw can be rotated up and down along a vertical pitch scale marked in millimeters. The two frames are kept together by crossbars E1 and E2. According to the Hooke's law, the law states that within the limit of elasticity, the stress applied is directly proportional to the strain produced. That is, the extension produced in a wire is directly proportional to the load attached to it. So, longitudinal stress is equal to mg upon pi r square, and longitudinal strain is equal to small l upon capital L. The Young's modulus, the ratio of longitudinal stress to the longitudinal strain. So Y is equal to mgl upon pi r square L. Capital L is the length of the wire. Small l is the extension for a load m. R is the radius of the wire, and g is the acceleration due to gravity, while capital M is the mass added in the hanger. So the procedure part 1, to find the area of cross section of the experimental wire. So A part, that is to find the zero error correction. So we are using micrometer screw gauge to determine the area of cross section of the experimental wire, whose least count is 0.001 centimeter, and the zero error correction is 0.025 centimeter. The part B is to find the area of cross section of the experimental wire. So serial number, MSR, CSR, TR, corrected diameter, average corrected diameter, radius of the wire, and finally area of the wire is given. So take 3 readings and finally you get area of the wire A is equal to 1.45 into 10 raised to minus 7 meter square. Now the part 2 is find the elongation of the wire after application of weight. The original length of the wire, that is capital L, is equal to 2.45 meter, which is given. The gravitational acceleration g is equal to 9.81 meter per second square. The observation table is as shown. Load M, then weight mg, spirometer readings, load, unload and mean, elongation, stress, strain, and Y. So after doing all these calculation, we get the y value, mean y value is equal to 2.34 into 10 raised to 11 Newton per meter square. The results from this experiment are: standard value of the Young's modulus of given metallic wire is 2 into 10 raised to 11 Newton per meter square, while the Young's modulus by experiment is 2.34 into 10 raised to 11 Newton per meter square, and the Young's modulus by graph is 2.65 into 10 raised to 11 Newton per meter square. Interpretation of results. The error in the measurement is equal to known or the standard value minus experimental value. Answer is minus 0.34 into 10 raised to 11 Newton per meter square. Conclusion and the recommendations. Young's modulus of given material is determined.